I hope. Oh, there it goes. So I'll go ahead and, just mistimed all. Complain, complain, complain. Okay. So I'll just go ahead and hit that, and then that stuff will reappear again as if it's supposed to appear later. I know it's written real small. Of course, we'll print a version of this PowerPoint and put it online if you wanted to read. That above statement, I guess I should have put in parentheses. I forgot to do that after first hour. They think I'm plagiarizing. But I stole those exact sentences from this link here. If you can see right here, it says UCLA. So, another college class kind of verification of what we're doing here. If you take stats in college, I said the one thing I hope is you're sitting in that stats class saying, oh, yeah, I remember I see this before. But I do like this because it kind of sets what we're doing today. It is not greatly, vastly new. All the steps are going to be very similar. So it's a nice way to kind of do our Monday, get tomorrow off, and then blah, blah, blah. So, all right, there we go. Good. I always love when that comes up. Just about to say something there. The one sentence that I like about this is we're testing the difference between two parameters. So we're comparing two situations that have, some sort of parameters out there that are accepted as truth. And then from that, we get some samples from these two different situations and compare them. So, we just had that big vote. So who is more likely to vote in an election, Democrats or Republicans? So here's the setup. We will have some sort of mean percentage of Democrats out there population-wise that vote. Then we have some mean amount of people that are Republicans that vote. Those are two different parameters maybe thrown out there. Then we'll make some sort of presumption. Hey, I bet you, Democrats and Republicans equally vote. Well, then let's get a sample and see if that's actually true. So that's kind of the idea of what is happening here. And of course, they come up with some other ones. Then I put that last sentence myself, which I should have put outside the quotes. The Null Hypothesis states that there is no difference between the populations. I guess this is just how they set it up. So going back to that, the Null Hypothesis would be there is no difference between how many Republicans and how many Democrats vote. All right. So then the alternative hypothesis may be one thing or the other. The Democrats vote more than Republicans or vice versa, depending on how you construct your situation. So that little highlighted thing there, I'm sorry, that little hyperlink thing there is where I got this from. Oh, I guess I'll hit it. I'm afraid what's going to happen though. Working. There. Okay. So doesn't that look thrilling? But this is what this person had online with a lot more math and so on and so forth. Interesting stuff. Where I thought that one comment was at the beginning was good for us. Okay, hitting the next thing. There we go. Now, this is something based off what you said, I think earlier. What you usually do with these is the null hypothesis always in terms of equal, right? And that went back to way back to our candy bar example as you write this down. We don't remember the candy bar. The population of candy bars has 58 grams of. It's 58 grams. That's how much it weighs. Is that right? Grams weight. All right. We wouldn't really care if it was more than 58 because we're winning in that case. We really care if it's less than 58. So even the guy in JB Statistics said this back then. That the null hypothesis may say equal, but we could change it to greater than or equal because we're happy in either case, and that's kind of the way we've been doing these from here on out. Today, when we're looking at these, the null hypothesis will always be the case where there is no difference between the two populations, all right? And then this is important for one of your parts of your formulas later. And then the alternative hypothesis is some sort of possible combination of what we have below here, which I'll go ahead and hit. And then this next one will fly in as if it wasn't here. Wait, there it goes. And then, it flies in. Now it's here. Okay, because the incompatibility of these two programs. So this is the same. Get that head up, man. Every day in my class you sleep because you're too comfortable. I'm coming at you. Here we go. Gonna get that ugly face right in yours. Every day she gets so comfortable. Then I got to wipe off the drool off the desk at the end of the class. Okay, so now looking at the null hypotheses. I did keep them in terms of, the exact complement of the alternative hypothesis. But in AP Stats, pointing at the student that's in it, these are always equals, correct? So I guess if you go to college and they do that, well, my teacher in high school did this, well, he's just a high school teacher. That's what they'll say. All right. I forget what I have to do here. Okay. Hey, good. My page is all screwed up. Okay. Formulas you will need, which I'll pause after this. I'm not going to hit that link again. And I tried to type this in math type, and it just wasn't working out, and I got frustrated. So I pulled up McGrath's writing from her old notes just to have it appear here. This is the standard error. And again, remember what is happening. You have two population parameters maybe thrown out there. This is the one, I guess I should have explained this further, it was on the previous page. In the unlikely scenario, again, that the standard deviation of both populations is known. So that is why you see lowercase sigma in this. All right, so up in the top here, this is, now what do these notations mean? Well, this would be the standard deviation. Let's go back to that Democrats and Republicans. The standard deviation of the Democrats squared, okay, we got to understand this, divided by the sample of the Democrats you pulled off and say, hey, do you vote or not? And then you find out, what the mean is of that, or blah, 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 blah. Plus, this is standard deviation 2 squared. This is the standard deviation of the Republicans, let's say, divided by how many Republicans you sample to see if there's some sort of situation going on there. And it's the square root of all that. So number one, make sure only the top number squared, just so you understand how the formula works. This is called the standard error for whatever two cases you're comparing. Again, I'm not going to go over that formula. I'm not saying I understand where it comes from. Next. Oh, I forgot to draw my arrow. I told you. I'm going to draw it now. Once you get this number, maybe I'll draw it now. Is pen working? Thank you. All right. Then that number shakily goes in the bottom of your next formula. So A, you find the standard error. B, you find the z-score. And then once you get that accomplished, everything else is the same. Once you get the z-score, you go find the area. And then depending on what kind of test it is, you find the p-value. Then you compare p to alpha, which they forced me writing that down because the PowerPoint and Camtasia don't work well together. Okay. All right. So let's go back up to here. This is the mean of the sample, let's say of Democrats again, because Democrats first, minus the mean of the Republican sample, close, minus the difference between the population parameter means. Now remember what we assume, or we assume, what the null hypothesis is actually made to be. The null hypothesis is there is no difference between these two things. Then maybe the alternative hypothesis will prove otherwise. Not prove, at least give evidence that. So this number, what's a number minus itself? What's equal things being subtracted? What do you always get? 0. So this is always going to be 0 because of what the null hypothesis actually states. So that's why I was making a big point about that earlier, so that you know that this is the case for this particular formula. Then, let's see what actually happens here. So here are steps that we're going to do, and they're almost exactly the same. You're going to state the null hypothesis, the alternative hypothesis, which one's the claim, what's the type of test. And then I didn't feel like writing these notations, but you identify X bar, sigma, and n for both samples, and then make sure you read what is your alpha. Same old, same old. Number 3, I put together. First of all, calculate that standard error. Those are our formulas. And then move that number into the z-score and find the z-score. And now what I'm talking about is everything else is the same of what you've been doing. Find the corresponding area and calculate the p-value. And then make a decision back again to comparing p and alpha with the same comparison. Oh, let it fly in now. All right. If p is less than alpha, reject h sub 0. If p is greater than or equal to alpha, fail to reject. And hopefully we're getting good about what those mean in the real world questions. Certainly have to pause this to give you a chance to write this down. If you can see it. I did not hit that. Ah, son of a. Oh, great. That's going to shut down on me. That means the video is going to be bad. Don't do it. Come on, don't do it. Don't do it. I'm begging you. I'm talking to the machine. Remember when I called this a jerk? Was that in this class? Well, look at it. Who does this? Jerks. I don't know what to do with myself. Enter. There's been some, I wonder if it has to do with those cutouts that I put in there. I don't even know what to do. Start test man. I hope this is all taping. Slideshow? Is that what I'm doing? Okay, I think we got it. Let's see if we could just add this on here. Got all this rigmarole. Okay, and then yeah. Okay, all right. We're there. That didn't take too long. Sorry, computer, for calling you names. Okay, all right. So mean households income for Visa and American Express. The company claims there is a difference in those. That's the first sentence. So remember how the construction of this works specifically to this one? What is the null hypothesis? Null hypothesis always has to have what in it? Equal. So what's the null hypothesis? They're exactly equal because the claim is saying that they're what? What's the claim saying? Not equal. Got one person listening or answering. There we go. Boom. So the claim is that they're not equal. And again, trying to get the whole construction of this scenario, we have Visa card population parameter average, and then we have American Express. So we have two population parameters, and what we're trying to say something about the parameter, which you don't actually get to see what it is are they equal or are they not? That's it. Okay, then the next part, and I'll just leave this up there when we're done. I'll end the video and then leave this up here for you taking this down if you want. Identify the sample mean, their deviation that is known for the population because it's given in the question, which is not likely. Remember we talked about z-tests and t-tests. T-tests are more likely not to know this population standard deviation, and n for both samples. And then also find in the reading what is your level of significance, which is 0.05 that's already given. So when you look at Visa, reading out and pulling out the information, they say, I should have put a $sign on there, but the average income is $60,900, and that was from that sample. So in a random survey from a sample of 110 Visa card holders, that was their average salary. Sorry, struggling for the words right now. Then you took 100 American Express people and found that their mean salary was $64,300. Somehow, some way, maybe through statistics over the years of American Express and Visa, they decided to call it a population parameter, that the standard deviation is 12,000 and has been for Visa for so many years. We're going to call it a population parameter. I'm just trying to talk out loud as people are writing how these population parameters, how the standard deviation for the population might be expressed and why they think they know it. Okay, then calculating the standard error and then the z-score after that. I leave it up to you, and I did have some people do this after I closed the note session, I guess you call it. It's up to you to test, can you type that in and actually get that answer? But actually, this one's a little bit easier. I will write this up here. I didn't write it first hour. Sorry, first hour. You seem to get short-changed a lot. But in any calculator, son of a nutcracker. Okay, in any calculator, it forces this on you, right? That little square root bar. Even if you're not, you're using a more upgraded one, it just does a square root, and then the bar just keeps going. You don't have to do anything after this. You can put 12,000. Don't even need the comma. Square it, so that would be a caret. Carrots. Divided by 110. And you just keep going because you can't. You should not close that square root. It's a square root of all of this. The square root of the fraction plus the fraction with the squaring. And then plus 15,000. So there really should be no reason why we're not getting this right. Divided by a hundo. And then you could close the parentheses after that, or you don't even have to. Just press enter. So this actually is a lot easier than all the other ones we've had. Okay, then if you notice over here, that number goes down in the bottom of our z-score formula. And then up at the top, look at what's right here. What's right here? What number? 0, because the null hypothesis states that American Express and Visa people have the same income. So same income minus the same income would be 0. All right? Blah, 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 blah. We do have a hand up and wait till the end.
Wait, just real quick.
Oh, boy. He's forcing it upon me, the question. Go ahead. You know what? You're right. This first hour said that. I said, be quiet. You kids always have something to say. And then I noticed I was wrong. It's of 100 people. It should say a survey of 100. A hundo got cut off up in here. My bad, dogs. Roof. No, I'm not perfect. Everyone knows that, by the way. We state it every day. All right. Okay. Then the area, you look it up on the sheet, negative 1.80. Where you going? I'm a student leaving. That's it. I've had enough. And then, me too. Double it. And then you make your conjecture about comparing P and alpha. So P is 0.0718. It's a two-tailed test, so you do want to double it. Remember that from everything we've been doing up to this point. And then you make a decision comparing those. Now, when P is greater than alpha, that is a case where we fail to reject. Now, we got to get this figured out. So we fail, I did it again. We fail to reject this. So that means, in a way, we reject this. Or, so this is a fail to reject, but I want to make it in terms of the claim when I write my final sentence. So this is the last time I should have to do this. So we reject the claim then, or we say there's not a sufficient evidence or not enough evidence to support the claim. So even though this is, and I started to think about this out loud with you guys, even though there is a bigger average with this American Express holder compared to the Visa. You okay back there? Maybe it's just not enough people to have enough evidence to support it. So if we did like 1,000 and 1,000, maybe then, and these numbers were the same, then it would be enough evidence. I don't know. There's a lot of things going on in there why this happens, I guess. So this maybe is not a big enough spread, or there's just not enough people. So there's certain reasons why this ends up being what it is.